So we're just going to look at this word dilation. Okay. Now, I was using words like stretched and squashed before, and they're good words to describe things. But let's just mention this word dilation because it might come up, and it's a counterintuitive word in the mathematical context. In some other contexts, I think it makes good sense. In science, for example, biology, they talk about the dilation of your pupils and things like that. That's a slightly different use of the word. It still has to do with stretching and squashing, but I think they're sort of opposite in the intuition aspect. Let's have a look at this case. So we've once again got that same old curve, f of x, and let's look at what happens if we have f d of x. Now, what I want to focus on is when I make the value of d change into 2. Now, it's very obvious what's happening. We get that slider and we slide it across and we eventually get to about 2. Let's see, there we go. And you can see that the graph has counterintuitively become slimmer, even though a 2 might indicate to you, you might think it should be twice as wide, okay? But what's actually happening then there is, when d equals 2, we actually have a dilation factor of 1/2, okay? And we have to get our heads around that, okay? Now, that's one case. Now, what about if I change it again and I go to this other graph and we're starting off with g equals 1. Same old situation, we're still going to dilate it. This time, let's go down to 1/3, let's say, approximately. 1/3, there, it's around about there. Okay, we can see that it's gotten much wider by a factor of 3. So this time I'm going to change my words here and say when it equals 1/3, then the dilation factor is in fact 3. Okay, so there's a bit of counterintuitive wordage to use when you ever use this word dilation. So we want to get used to that idea.